Hello people, today we are going to learn about planning process or project management process, plan quality management. Plan quality management is the process of identifying quality requirements and standards of the project and its deliverables, documenting how the project will demonstrate compliance with relevant quality requirements. The key benefit of this process is that it provides guidance and direction on how quality will be managed and validated throughout the project. The input involves our project management plan, stakeholder register, risk register, requirement documentation, enterprise environmental factors, and organizational process asset. The tools and techniques used are cost benefit analysis, cost of quality, 7 basic quality tools, benchmarking, design of experiments, statistical sampling, additional quality planning tools, and meetings. The outputs are quality management plan, process improvement plan, quality matrix, quality checklist, and project document updates. So let's learn about input. The first input is project management plan, which consists of scope baseline, uh, schedule baseline, cost baseline, and other management plans. So in scope baseline, there are three things to remember: project scope statement, work breakdown structure, and WBS dictionary. The project scope statement contains the project description, major project deliverables, and acceptance criteria. The product scope often contains details of technical issues and other concerns that can affect quality planning and that should have been identified as a result of planning processes in the project scope statement. The definition of acceptance criteria may significantly increase or decrease quality cost and therefore project cost, satisfying all acceptance criteria that the needs of the sponsor and customer have been met. The work breakdown structure identifies deliverables and the work packages used to measure project performance. The WBS dictionary provides detailed information of WBS elements. Then there is schedule baseline, which documents the accepted schedule performance measures, including start and finish date. The cost baseline document and the accepted time interval being used to measure cost performance. And other management plans contribute to overall project quality and may highlight actionable areas of concern with regard to the project quality. The next input is stakeholder register, which aids in identifying those stakeholders possessing a particular interest in or having an impact on quality. The next input is risk register, which contains information on threats and opportunities that may impact quality requirement. The next input is requirement documentation, which captures the requirement that the project shall meet pertaining to stakeholder expectations. The components of the requirement documentation include including product and quality requirement. The requirements are used by the project team to help how quality control will be implemented on the project. The next input is enterprise environmental factor or organization process asset. The EEFs that influence the plant quality management process include governmental agency regulation, rules, standards, and guidelines specific to application area, working or operating condition of the project or its deliverables that may affect project quality, and cultural perceptions that may influence exception about quality. The OPs that influence the plant quality management process include organization quality policies, procedures, and guidelines. The performing organization quality policy, as endorsed by the senior management, sets the organization's intended direction on implementing its quality management approach, historical databases, lessons learned from the previous phases or projects. The tools and techniques used are cost-benefit analysis. The primary benefit of meeting quality requirement include less rework, higher productivity, lower cost, increased stakeholder satisfaction, and increased profitability. A cost-benefit analysis for each quality activity compares the cost of the quality step to the expected benefit. The next tool and technique is cost of quality. Cost of quality includes all costs incurred over the life of the product by investment in preventing non-conformance to requirement, appraising the product or service for conformance to requirement, and failing to meet requirement, that is rework. Failure costs are often categorized into internal, found by the project, and external, found by the customer. Failure costs are also called cost of poor quality. So here there is the cost of conformance, which is money spent during the project to avoid failures, and here is the cost of non-conformance, which is the money spent during and after the project because of failures. So in case of conformance, we deal with prevention cost and appraisal cost. Prevention cost means build a quality product by training, document processes, equipment, time to do it right. In case of appraisal cost means assessing the quality by testing, destructive testing, loss, and inspection. In case of non-conformance, there are two kinds, internal failure cost and external failure cost. Internal failure cost is failure found by the project, requires rework and scrap, and external failure is found by the customer, deals with liabilities, warranty work, and lost business. Seven basic quality tools is another tools and techniques. So let's see one by one. The first one of the quality tool is cause and effect diagram, also known as fishbone diagram or Ishikawa diagram. The problem statement is placed at the head of the fishbone and used as a starting point to trace the problem's source back into actionable root cause. Asking why until the actionable root cause has been identified or until the reasonable possibility on each fishbone has been exhausted. Like here, there are five things we are considering for fishbone diagram. Here is the problem, which is missed free throws. The first thing is method, second thing is material, and third thing is people. And here environment and machine. So asking why until we get the answer. So balance, bending knees, aiming point for the method. Then for material we are using grain, air pressure, size of the ball, lopsidedness. And people is dealing with motivation and concentration. Then there is one more thing, training, conditioning, consistency, adjustment to other variables. Similarly, for machine, we think about the rim size, rim alignment, rim height, rim plate tightness, and blackboard stability. And for environment, we think about the wind, gust, sun, or rain, open air environment. So considering all these factors and asking why and until the actionable root cause has been identified, uh, we can find out the root cause by using this cause and effect diagram, which is also called fishbone or Ishikawa diagram. The next quality tool is flowchart, also referred to as process maps, because they display the sequence of steps and branching possibility that exist for a process that transform one or more input into one or more output. The next thing is check sheets, also known as tally sheets, may be used as a checklist when gathering data. Check sheets are used to organize facts in a manner that will facilitate the effective collection of useful data about a potential quality problem. Next thing is Pareto diagram, which exists as a special form of vertical bar charts used to identify the vital few sources that are responsible for causing most of the problem's effect. And next thing is histogram or special form of bar charts are used to describe central tendency dispersion and shape of statistical distribution. Unlike the control chart, the histogram does not consider the influence of time on the variation that exists within the distribution. Then next thing is scatter diagram, which is plot ordered pairs x and y are sometimes called correlation chart because they seek to explain a change in dependent variable y in relation to a change observed in the corresponding independent variable x. The direction of correlation may be proportional, positive correlation, inverse that is negative correlation, or a pattern of correlation may not exist, which is zero correlation. The next thing is control charts are used to determine whether or not a process is stable or has a predictable performance. Upper and lower specification limits are used on requirement of the agreement. They reflect the maximum and minimum values allowed. There may be penalties associated with exceeding the specification limit. Upper and lower limit are different from specification limit. The control limits are determined using the standard statistical calculation and principle to ultimately establish the natural capability for a stable process. For a repetitive processes, the control limits are generally set at t plus minus 3s around a process mean that has been set at s. A process is considered out of control when data point exceeds the control limit, 7 consecutive plot points are above the line of the mean, and 7 consecutive plot points are below the mean. So let's look in the picture to understand more. Here is the picture, one second. Yeah, this is the control chart. It is kind of small. This is the S, which is the mean. This is the specification limit upper control limit, and this is specification lower control limit, and above that is the out of control. So whenever we plot points around the mean, if 7 consecutive points are above the mean or below the mean, then the thing is out of control. And if it goes above the specification limit, that is this line, then there is something seriously wrong with the project. The next input is benchmarking. Benchmarking involves comparing actual or planned project practices to those of the comparable projects to identify best practices, generate ideas for improvement, and provide a basis for measuring performance. Benchmark projects may exist within the performing organization or outside of it, and can be within the same application area. Benchmarking allows for analogies from project in a different application area to be made. The next tool and technique used is design of experiment, which is a statistical method for identifying which factors may influence the specific variable of the product or process under development or in production. Design of experiments may be used during the plant quality management process to determine the number and types of tests and their impact on the cost of quality. The next tool and technique is statistical sampling, which involves choosing part of population of interest for an inspection, for example, selecting 10 engineering drawings at random from a list of 75. Sample frequency and sizes should be determined during the plant quality management process, so the cost of quality will include the number of tests expected, scrap, etc. Additional quality planning tool can be brainstorming, which is a technique used to generate ideas. Then there is force field analysis. These are diagrams of the forces for and against changes. Then nominal group technique, which is used to allow ideas to brainstorm in the small group and then reviewed by a larger group. Then there is quality management and control tools. These tools are used to link and sequence the activities identified. This is the diagram. This is a cause and effect diagram, which is also called fishbone or Ishikawa diagram. Here we put the problem and then for every factor like machine, people, environment, etc. We ask why depending on the factors involved to get the root cause. Here is the flowchart, is the check sheets or tally sheets. This is the Pareto diagram. This is histogram. This is a scatter diagram, and this is a correlation line. The more closer the dots are, the more it's correlated. If the dots are further away, then it's not correlated. I've already explained about the control charts. The output is quality management plan. The quality management plan is a component of project management plan that describes how the organization's quality process will be implemented. It describes how project team plans to meet the quality requirement set for the project. It may be formal or informal, detailed or broadly framed. The style and detail of the quality management plan are determined by the requirement of the project. It should be reviewed early in the project to ensure that the decisions are based on accurate information. The benefit of this review can include sharper focus on the project value proposition and reduction in the cost and the frequency of the schedule overrun that were caused by the rework. The next output is process improvement plan, which is a subsidiary or component of project management plan. Process improvement plan details the steps for analyzing project management and product development processes to identify activities that enhance their values. And the areas could include process boundaries, which describes the purpose of the process, start and end of the process, its input and output, the process owner, the stakeholder of the process. And the next area is process configuration, which provide graphical depiction of the processes with interfaces identified used to facilitate analysis. The next thing is process metrics, along with the control limits allow analysis of process efficiency. The next thing is target for improved performance, guide to process improvement activities. The next out is quality metrics, which specifically describes a project or product attributes and how the control quality process will measure it. A measurement is an actual value. The tolerance defines the allowable variation to the metric. For example, if the quality objective is to stay within the approved budget by plus and minus 10%, the specific quality metric is used to measure the cost of every deliverable and determine the percent variance the approved budget for that deliverable. Then there is quality checklist is a structured tool, usually component specific, used to verify that a set of required steps has been performed. Based on the project requirement and practices, checklists may be simple or complex. Many organizations have standardized checklists available to ensure consistency in frequently performed tasks. In some application areas, checklists are also available from professional associations or commercial services provider. Quality checklist could incorporate the acceptance criteria included in the score baseline. And next output is project document updates, which updates the relevant document related to quality management. So guys, I hope you got some insights on quality management process. So come back to my channel or subscribe to my channel for more videos on PMP and other things. Thank you very much for watching. See you soon.